Hey friends. Okay, so this is our second lesson in our rational expressions unit for 30-2. And what we want to tackle today is rational uh, equivalency and non-permissible values. Okay, so really two separate things, but we're going to lump them together because you guys are going to rock at it and it's all going to be great. Okay, so we'll kind of spend half and half as we go. Okay, so in this unit, I'm just going to hide my head for a quick second. In this unit, we will learn how to work with rational expressions, a fancy phrase for fractions that have variables. Okay, I can't find myself. There I am. Okay, we will revisit what we learned way back in junior high, how to add, subtract, multiply, and divide fractions. But our fractions will have polynomials in the numerator and denominator, which means we will also get to factor the numerator and the denominator. Okay, so what we want to do first is just some basic fraction rules, just to remind ourselves of the basics. Okay, so consider the fractions 4/8 and 12/24. What can you say about this pair of fractions? Well, I want you to kind of think through this. Ultimately, I want you to say that they're the same fraction. Okay, that's where we're going. But why? Well, I could say, hey, I can take 4 and multiply by 4. Sorry, and multiply by 3. I had to pay attention to the numbers I was looking at. So 4 times 3 gives me 12. Okay, and then 8 times 3 will give me 24. So if I take the top and bottom and multiply by the same number or divide by the same number, I will actually have fractions that are the same. Now, visually, why is that? Essentially, it's like this, okay? If I took, what shall I do here? So that's kind of 8 pieces, and I'm going to take 4 of them, okay? If I wanted to switch that into something over 12, essentially what I could do is I could just take this exact same picture and what's the easiest way to divide this into 12? I would want this now to become 3. So if you kind of ignored that blue line now and I did this instead, so I put a line here and here, and then sort of I'll just erase that blue line. Okay, roughly, that's a little off in my drawing, but now I can see, hey, now there's 1, 2, 3 by 1, 2, 3, 4. So there's 12 spots there. And, oh, but I want 24. So then I'm just going to cut it all in half one more time. So I'm going to go, sorry, I can't get my ink going here. Okay, so cut that in half, cut that in half, and cut that in half. Okay, so now I've got 1, 2, 3, 4, 5, 6 by 4. So I have 24. And how many of these do I have shaded? 2, 4, 6, 8, 10, 12. So visually, now I'm showing you that 4/8 and 12/24 is the same picture. Okay. Okay. The other thing we can do is reduce those fractions. And so we can say, okay, well, 4/8 reduces to 1/2. 12/24 also reduces to 1/2 because they reduce to the same one, they're going to have to be equivalent. Okay, so all of those reasons are valid support to say, hey, yep, these fractions are in fact equivalent. Okay, so these fractions are equivalent. They both reduce to 1/2. That was one way I said it. We could also look at the fact that I could take the first one and multiply both the numerator and denominator by the same thing, which is 3, and it would create the second fraction. Again, just a reminder, numerator is the top, denominator is the bottom. Okay. Awesome. Okay. What is another equivalent fraction to the pair above? Well, I've already given you one. I said 1/2. But then if we played with 1/2, we could think, okay, what other ways could we represent 1/2, right? Well, 5/10 would work. Lots of different things would work. 80/160 would work. Anything you want to do, as long as you're multiplying the top and the bottom, the numerator and the denominator by the same thing. This would work. It would make it equivalent if you're multiplying by the same thing, or if you're dividing by the same thing. It does not make equivalent fractions if you are adding or subtracting. Don't do that. Okay, it has to be multiplication or division. Okay. How could we find any equivalent fraction then? Just what I said, we could multiply both the numerator and denominator by the same factor. Or divide both the numerator and denominator by the same factor, okay? Okay, let's look at a more complicated rational expression. So this time we have 6x over 9y, okay? 6x over 9y. Describe how to find any equivalent rational expression and state 3. Well, again, it's the same answer. To find any equivalent rational expression, we're going to multiply or divide both the numerator, the top, and the denominator, the bottom, by the same factor, okay? That factor could be 2, could be 3, could be 18 billion, it could be x, it could be a, could be y, doesn't matter, okay? So I've given you 2x over 3y, where I divided both of these by 3. I've also given you 12x over 18y. Here I multiply both the top and the bottom by 2. Or I could say 6x squared over 9xy. There I multiply both the top and the bottom by x. Okay? So all of those are equivalent. If I was to think of them visually as a picture, just like I did with that 4 over 8 versus 12 over 24, it would be the exact same picture. The only difference is kind of how many pieces I'm splitting that picture up into. Okay? Awesome. Okay, so to create rational expressions, we simply multiply or divide both the numerator and denominator by the same amount. Okay, this amount could be a number or it could be a variable, just like we did in that last example. All right, awesome. Determine an equivalent rational expression for 4x squared plus 8x all over 4x by either multiplying or by factoring and then dividing, okay? Now, first comment I want to make while my head is hidden is just be careful. You don't want to look at this guy here. Sometimes we look at this and we say, oh, look at that. I can just divide that right out. I can't do that unless I can do it to both of them, okay? So just be careful of that. We're going to talk lots about that as we go, but just don't look at that 4x and 4x and just immediately go there, okay? There are some rules we have to kind of abide by because the 4x squared plus 8x is one item. It's kind of glued together. So if I wanted to multiply, I'm going to choose to multiply by 2 over 2. Just, I picked a number, doesn't matter. But I have 4x squared plus 8x over 4x. I multiply by 2 over 2. So that means I'm multiplying the top by 2 and the bottom by 2. Remember, just for clarification, this 2 over 2 is essentially 1, right? And anything times 1 is itself. So doing this, I'm not changing the number. I'm just making it look different, okay? Now, you just have to remember, if I do that and there's 2 terms up here, that multiplication of 2 will have to apply to both of those, okay? It's like the 2 is getting distributed. So I'm going to get 8x squared, that's 4x squared times 2. And then plus 16, that's my 8x times 2. And then on the bottom, I get 4x times 2, which gives me 8x. Okay. If I was to factor, this is right back to what I was doing in our first video. I'm looking for the greatest common factor of 4x squared plus 8x, and I see that it's 4x. So I pull 4x out to the front, and that leaves me with x plus 2. Now that's a multiplication statement, okay? Remember at the beginning I said, oh, you got to be careful with that 4x and 4x. Now this 4x is outside of the addition, so it's all by himself. These guys now will divide out. Whereas if I hide my head here for one more second, that's different than up here, because up here, these guys are attached to each other, okay? So you just got to be super, super careful of that. But down here, I am totally good to go and divide out those 4x's because it's multiplication now, okay? All right, so that's going to leave me with x plus 2. Yay, okay. Next up, for each of the following, determine if the rational expressions are equivalent or not. So if they are equivalent, I should find, essentially, it's sort of like a scale factor, right? If you've talked about that in other courses. But essentially, I need to find some sort of a number that I'm either multiplying everything by in the first one to get to the second one, or I'm dividing everything. So if I took a look at how do I go from from 9 to -18, I'm going to multiply by -2. So let's see if I do that all the time. 3x times -2 gives me -6x, so that's okay. And -1 times -2 gives me +2. So yes, these guys are equivalent to each other. Remember, equivalent just means they're the same thing, okay? It's the same sort of picture. So yes, they are equivalent. Each number on the left fraction is multiplied by -2 to obtain its corresponding number on the right fraction, okay? All right, let's try this. Same sort of question, same sort of thing. To go from 2 to -1, well, I'd have to divide by -2, right? 2 divided by -2 is -1. -2x divided by -2 is +1x. 4 divided by -2 is not 2x. Okay, so that one was not divided by -2 properly. So no, these ones are not equivalent. Okay, so no, they are not equivalent. Each number on the top left fraction is divided by -2 to obtain its corresponding number on the right. But in the denominator on the bottom, the 4x is divided by 2 instead of -2. Okay? Yay. Okay. Now, we have one last thing to consider when working with fractions that have variables in the denominator. What is the only number we can never divide by? Now, hopefully you know that answer. Hopefully you're yelling at your screen right now and you're saying, it's 0. Yes, it's 0. Okay, I can't divide by 0. I just want to talk very quickly as to why. I don't like it when kids just think it's just because my teacher told me so. I want you to understand why. If I went 0 divided by 5, that is totally okay. That says take nothing and put it into 5 equal groups. I can totally do that. I can take 5 equal groups of nothing and I'd be left with nothing. So 0 divided by 5 is 0. That is totally okay. Okay, but this, friends, this says take something and put it into equal groups of nothing. Well, no matter how many equal groups of nothing I give you, I am never going to get something out of that. That's impossible. Okay, so I can never have a 0 on the bottom of a fraction. Now, if we have variables on the bottom of a fraction, then as soon as we write a variable, we are saying that variable can be anything we want. So if that's not entirely true, we need to state, these are called non-permissible values or restrictions. We need to state what that variable is not allowed to be. Okay, and where that comes from in rational expressions is I can't have the variable be something that would cause a 0 on the bottom of a fraction. Okay, so whenever we have a variable in the denominator, we must find what values would make it equal to 0. We call this the non-permissible values. Sometimes we abbreviate that as NPVs or restrictions. Okay, now I'm just going to hide my head here so that you have that full slide, just in case you're taking notes along with me. Okay, awesome. And now we're going to try a few of these. So state the non-permissible values for each of the following. Okay, so in this first example, we have 2 over 7x. So what we're trying to decide is what value for x, what value for my variable would cause this whole thing to be 0. Now, the easiest way to do that, friends, is just to take the denominator and set it equal to 0. That's what we don't want. So I'm actually going to say 7x can't equal 0. That's what that slash through it means. But then you're just going to solve by isolating for x, right? So I'm just going to divide by 7, and say x can't equal 0. 0 divided by 7 is 0. Now, you don't have to do that every time. If you notice that 7x and you know right away that x can't be 0, that's totally awesome, friends. You just go ahead and do that. But if you're ever unsure, you have strategies here. Just take the bottom, set it equal to 0, and solve for x, and that will be your NPVs. Okay. All right. Let's try this one then. 5x plus 1 over x minus 7. Okay, again, what would cause a 0 on the bottom of the fraction? Take note, x actually can be 0 here. It's not about x not being able to be 0. It's about the denominator not being able to be 0, right? If x was 0 here, that's totally okay. I'd get a -7 out on the denominator, and I can totally divide anything by -7. Okay, so what x actually can't be is +7, because that would cause me to have a 7 minus 7, and that would give me a 0. Okay, so x can't be 7 on that one. Okay, 9x squared over 3x minus 1. Again, x being 0 is totally okay here. I'd get out a -1. Lots of kids look at this and say, oh, it's the opposite of the -1, so it has to be +1. That's actually totally okay here as well. If I plugged 1 in for x, I actually get out 3 minus 1, which is 2. That's no problem. So if you're unsure, you take the denominator and you set it equal to 0. Now I'm setting it not equal to 0 just to make sure I remember that I'm looking for the restrictions. Algebraically, if I want x all by itself here, I'm going to add 1 to both sides. And then I would divide both sides by 3. So x can't be 1/3. Okay? X can't be 1/3. Why? Because if I plugged x as 1/3 in, I would get a 0 on the bottom of my fraction, and everything would fall apart. Okay? Awesome. Okay, 10 minus x over 3x squared. 10 minus x over 3x squared. Again, I don't care about the 10 minus x, right? I'm allowed to have a 0 on the top. I'm just not allowed to end up with a 0 on the bottom. And so x can't be 0 there. Okay. Again, if you don't see that, go play with it for a second. Just take the denominator, set it equal to 0. I'm going to have to divide by 3, and then I'm going to have to square root. But the square root of 0 is just 0. Okay. Hey, we're rocking this. This is awesome. Okay, 9 over x squared minus x. Now, what I want you to see here, this is just getting a little bit more complicated. We're adding a little layer here, and the layer we're adding is factoring, okay? So you actually want to see in all rational equations and expressions, you want to see what you can factor first. On x squared minus x, there's an x that's common. So I'm going to factor that x out, and that leaves me with x times x minus 1. Okay, now this is back to really that last few examples I gave you on our first video. Remember, I don't want that to equal 0. Well, this is just the zero product principle then. Either that guy could be 0 or that guy could be 0. So this guy would be x can't be 0. This guy would be x can't be 1. So there are actually two non-permissible values for this one. If x was 0, this wouldn't work. And if x was 1, this wouldn't work. And by this wouldn't work, I mean we would get a 0 on the bottom of a fraction, and that would destroy our question. Okay. So x can't be 0 or 1. Okay, awesome. So now I've got -4 on the top and an x squared minus 1 on the bottom. I want you to see that. I want to get your factoring brain going here. I want you to see that as a difference of squares. Okay, so that is x plus 1 times x minus 1. And then again, I'm back to either one of those factors can't give me 0 because of the zero product principle. So Here, x can't equal -1 because that would cause a 0. And here, x can't equal +1 because that would cause a 0. Okay, so altogether, I would say x can't equal -1 or 1. Okay? All right. Now, this one's a little different. I'll hide my head for a sec. Write a rational expression that has non-permissible values of the following: x equals or can't equal -2 and x can't equal 0. So the question you're asking yourself is, what factors would I need on the bottom to create these restrictions? And so essentially what you're going to do is you're just going to take this and get everything over to one side so that it equals 0, and then that becomes your factor. So if I wanted that to equal 0, I would say x minus 2 equals 0, or sorry, x plus 2 equals 0. I just add 2 to both sides, right? So that's the factor that I don't want on the bottom. And then this guy is already set up, so that would just be a factor of x on the bottom. Okay, so if I was to create this, I would want an x and an x plus 2 on the bottom. Doesn't matter what I put on the top. Okay. All right. Perfect. Let's do another one of those. This time I want x can't be 7 and x can't be 1/2. Okay, so the x can't be 7, probably you're feeling a little bit more comfortable with based on what we did on the last one. You're going to bring that 7 over, so it'll be x minus 7 can't equal 0, which means that would be your factor that you'd want. This guy's a little trickier. To get 0, I don't want to just subtract 1/2 from both sides. These things always should be integers, not just any old rational number. So we don't want fractions in our factors is what we're saying here. So let's instead, we'll get rid of the fractions by multiplying both sides by 2 first, and then I'll subtract the 1 so that it equals 0. So that would be my other factor. So I would need to have an x minus 7 on the bottom and a 2x minus 1 on the bottom. Okay, x minus 7 on the bottom and a 2x minus 1 on the bottom. Okay, so let's just walk through a quick summary together. I'm going to hide my head here for one sec. Rational expressions are nothing more than fractions, but with variables or polynomials in the numerator and denominator. Okay. We can find equivalent fractions. That's what we started our lesson doing. So we can find equivalent fractions by multiplying or dividing the numerator and denominator by the same amount. When polynomials are involved, we may have to simplify by factoring and then dividing common factors out to determine if the expressions are equivalent. Since division by 0 is not defined, values of a variable that make the denominator equal to 0 are not permitted. That is, variables have restrictions, okay? Sometimes we call them restrictions, sometimes we call them non-permissible values. They both mean the same thing, okay? We must always find these and talk about them, even if it's not explicitly stated in the question, okay? That's a super important conversation to have. The very first thing you do in any rational question is you factor everything you can factor. Then you're always going to state restrictions, okay? You always have to interact with, okay, what is X not allowed to be, okay? All right, awesome. So that concludes video number 2 for this unit. Thanks for tagging along with me. Hopefully this has been helpful. And as always, thank you for sharing these videos with your friends and letting them know that they are out there. And thank you for subscribing to my YouTube channel. I really appreciate it, guys. If you have any questions, please get in touch and have some fun doing some homework. It's going to be awesome. Take care, guys.